Welcome to Lesson 7. Why do things change their speed or directions? This is for Activity 7.1. Now, 7.1 is out of the book. However, the first part is going to be using the handout that you picked up. So eventually we're going to analyze three objects that move in different ways to determine the relationship between the forces. But we're going to take a look at forces and what causes things to, say, speed up or slow down or move at a constant speed. So we're going to look at different scenarios first. So the expectation for you is to complete the type of motion change table for activity 7.1. So make sure you have the handout because you're going to be filling that in during this video. Now, let me ask you a question. What happens immediately after an object begins to move? Well, can you answer that? Well, you might be looking and say, well, it depends on the object. Some things stop. And that could be some things, immediately after an object begins to move, it stops right away. Maybe it didn't get very far. Some things slow down. If I threw, say the bowling ball, it wouldn't stop immediately. Well, maybe if it hit a wall or something, but more than likely would start to slow down right away. But do some things speed up? How about, say, a jet? Once it starts to move, it's going to keep speeding up until it gets to be as fast as it can be. So how about a baseball? What does a baseball do immediately after it is thrown? Does it stop? Does it slow down? Does it speed up? Well, it might depend on the circumstance. Now, speed up? Probably not. Usually it's going as fast as it can go once it leaves the hand. Is it slowing down? Does it stop? Well, how about if you threw it and it hit a wall right away? Well, then would it stop immediately? It kind of depends on the scenario again. So what does an airplane do when it starts to move? Does it stop? That'd be a pretty short flight, or if it just starts to move on the tarmac, is it going to stop right away? Does it slow down? Or does it speed up? So we're going to explore these questions, and we're going to explore um, types of movement. So for example, here's my car, beginning to move. What causes this car to begin movement? So let's just say, for example, I was driving a car and it's moving in this direction. And what forces could cause this car to begin to move? What's going to get it going? Now, you might look at the car and say, well, there's a lot to get it to go, or I don't believe it's going to go. I think this is a cool looking car. And even though technically it's not my car, I'd love to have a car like this riding around Baraboo. So, what type of forces would cause this car to begin to move? How about balance forces? Could balance forces cause these or cause this car to move? And if it's moving in this direction, what type of balance forces could it be? Could it be unbalanced forces? Well, think about it. Okay, if do balance forces cause things to move, or do unbalanced forces cause things to move? So if you said unbalanced forces, you're right. Unbalanced forces acting in a direction in which the motion occurs. So in order to get this car to move, you have to have unbalanced forces acting in the same direction as the car is moving. So go ahead, fill this in on your chart. Pause if you need to, write it all down. So let's look at that same car again. Let's say I want to stop it. What causes this car to stop? So if the car was moving in this direction again, and all of a sudden I wanted to stop the car, I put on the brakes. And yes, the brakes do work. What type of forces would cause this? And I don't mean, what type of forces like a semi truck, plowing into it, but balanced or unbalanced forces. What type of forces would cause this car to stop? Would they have to be balanced forces, or would they have to be unbalanced forces? And in what direction? So think about it a little bit. What are your thoughts? Could it be balanced forces? Well, no. Actually, it would have to be, let me get this right here. Let me move this out of the way and click on this. Here we go. unbalanced forces acting against the direction of motion. So it would have to be unbalanced forces, and it has to act in the opposite direction. Now, does this make sense? It can't be in the same direction, because if forces were acting in the same direction, wouldn't it cause the car to go the opposite way? So if we have forces initially acting in this direction, which causes the car to move, and you want to stop it, don't you have to oppose this motion? So in order to get something to stop, you have to have unbalanced forces acting against the direction of motion. That makes sense? So let's look at another scenario. So here's a different vehicle. How about slowing down? Let's say I didn't want to stop. I just wanted to slow down. So what type of forces would we need? So if we look at the forces, again, let's just assume the car is moving in this direction. If I want to slow down, what type of forces would I need? In which direction would I need those forces? So what are your thoughts? Should they be balanced? Should they be unbalanced? Well, if you said they're unbalanced forces acting against the direction of motion, you're right. So again, just like stopping, I have to have unbalanced forces acting against the direction of motion. Now, what would happen if it was balanced with this? You wouldn't get any movement, would you? Or would it continue to move at the same speed? Well, we're going to get to that later. But if we're slowing down, we want this force to be applied against this motion. But if we're just slowing down, we don't want it necessarily to be equal in a sense. So they have to be unbalanced forces acting against the direction of motion. Let's look at another scenario. So again, pause the video if you need to write this down on your chart. And don't forget to write it down on your chart. So here's a fourth scenario. How about I'm speeding up? So again, let's look at the direction of the car. So again, I'm driving the car forward. I'm not going in reverse. So if there's a force acting in that direction and I'm speeding up, so I'm driving down the road and I'm speeding up, what type of force would you need to act on this truck in order to get the truck to speed up? First of all, should they be balanced? Should they be unbalanced? In which direction? Should it act with this force or should it act against the force? What are your thoughts? If you were thinking that they need to be unbalanced forces acting in the direction in which motion occurs, yeah, you're correct. So if I'm speeding up, it has to go in the same direction as I'm going. And why is that? Well, if it's going in the opposite direction, how can it be speeding up? Because it would be opposing this motion, so it should be slowing down. So if I'm going 25 miles an hour and I hit the edge of Baraboo and I put on the gas and I want to speed up, that what has to happen is I have to increase this force in the direction that I'm moving. So if I want to go from 25 to 55, I have to have unbalanced forces acting in the direction in which motion occurs. So these first four scenarios were pretty straightforward, but let's take two different approaches. So how about if I'm moving at a constant speed? So I left Baraboo. I'm driving down Highway 33. I'm going 55 miles an hour. So first of all, let's look at the direction of the force. So again, I'm not driving down Highway 33 in reverse. I'm driving in this direction. What type of force would I need in order to move at a constant speed? So I get the car up to 55 miles an hour and I put it on cruise control and I'm just going down the road. I know I've got a ways to go until I get to Portage. What type of force would allow me to go at a constant speed? Balanced forces? Would it be unbalanced forces? What are your thoughts on this? If you're thinking unbalanced forces, well, you're actually wrong. There can be no unbalanced forces. And this sometimes is confusing. But listen, look at this a second. What would happen if you had unbalanced forces? Let's back up. Slowing down, unbalanced forces acting against the direction of motion. So if you had unbalanced forces acting against, you'd be slowing down. What was the other unbalanced forces? If we wanted to stop, you have to have unbalanced forces acting. Well, We want to move at a constant speed. So we're not stopping, we're not slowing down, we're not speeding up. All these are unbalanced forces acting against the direction of motion or acting in the direction of the motion. And then a constant speed. So once we get to constant speed, all the unbalanced forces have been used up. So if we have an unbalanced force, we're going to either be slowing down, we're going to be stopping, we're going to be speeding up. So if you're going to move at a constant speed, you have to have no unbalanced forces. That makes sense? Again, it's because all the unbalanced forces either cause you to speed up, it causes you to begin moving, it causes you to stop. So this one has to be no unbalanced forces. Well, let's look at another scenario. How about if something is motionless? Well, this might be the easiest one. In our last test, we talked about a rock that's not moving. So would you have to have balanced forces here? Yeah. So we've talked about this. There can be no unbalanced forces. In other words, the forces have to be balanced in order to get motionless. So it's the same thing for this right here. No unbalanced forces for constant motion or motionless. No unbalanced forces. And this goes along with Newton's laws, where he says in order to get something, well, it's inertia. Things in motion want to stay in motion. Things at rest want to stay at rest unless acted upon by a net force. Well, if you have no unbalanced forces, you have no net force acting on it because everything's balanced. So let's just quick review once. Make sure you have your sheet filled out and make sure you have all of these filled out. These are going to be important to know not only for class moving forward, but also for the test. And as always, if you have any questions, make sure you ask. Thanks.